Okay, it is time to start. So hello everybody, my name is Joshua Watt, and today I am going to talk to you about the super exciting topic of software bill of materials in embedded. A little bit about myself. I have been working at Garmin as a software engineer since 2009, making electronics for boats. We have been using Open Embedded in the Octa project to do that since about 2016. I'm a member of the Open Embedded Technical Steering Committee. I'm also a member of the Yocto Technical Steering Committee, and I am also on the SPDX technical team. And here's all the various ways you can contact me if you'd like to do that. So as a disclaimer, all opinions are my own and not that of my company or any of the projects that I'm working with. If it's not obvious, my area of expertise is Yocto and SPDX. I'm not here to sell that to you today. But a lot of my examples and stuff will come from that just because that's what I'm most familiar with. And also my background is in engineering consumer products. If you're in aviation or some other field, you know, some of these things may be applicable and some of them may not. But it can be different in different fields, and I understand that, but that's my background. So what exactly is an SBoM and why do I want one? And if you talk to people about SBoMs, you're going to get a lot of different answers to this question. And I kind of like this picture that I found as sort of an example of that, because depending on the direction you look at this shape, you're going to see a different shadow that isn't a complete reflection of what the shape actually is. And SBoMs tend to be the same way when people are talking about them. Depending on who you're talking to, they see them as useful for a lot of different things. And so it can be a little bit confusing about what they're actually good for and things like that, because people are going to tell you what their projection of them is and what they see them useful for. So we're going to go over a lot of the things that SBoMs are useful for to try to get a better picture of what they are sort of holistically, to try to see the actual three-dimensional shape of them. So one of the examples you'll see a lot is nutrition information for software. I think this is a really, if you'll pardon the pun, digestible way of approaching SBoMs because it's very intuitive, right? We all, eat food and hopefully look at the nutrition labels so that we can tell, what we're putting into our bodies when we eat. And nutrition information for software gives you an intuitive sense that it's a standardized way of describing what's actually in your software, right? And so that's very helpful and I think easy for people to start understanding what we're going for with this. The thing I don't like about the nutrition information is that it really misses out on the whole supply chain aspect of SBoM, so I think you can go deeper than this. You'll also see it described this way, where it's a relationship between components. So software is generally made up of a lot of different things that go into whatever the final product is. And those things have relationships to each other. So this comes from the NTIA framing document. You'll see there's all these different software components here, and then these are the relationships that link them together. And then the other thing that becomes important here is talking about what we don't know about our software. So as an example here, this Acme application, there's things that we know for sure this is, information about the software. There also might be things where, like, let's say there's something that's a known unknown. Like, we know the software has a license, but we don't know what it is. So that's important to actually annotate so that, you can understand where your deficiencies are. It can also be a standardized format for the exchange of information. So on the right-hand side here, you've got various entities, both internal and external. You might have a regulatory agency, such as the EU, or some related agency there. You might have an internal compliance team. You might have downstream third parties who are consuming your software, or something like that. And they all have questions for you. And these are perfectly valid questions that you need to be able to answer. And so one of the things that SBoMs can be useful for is as the communication method that you use to answer these questions for these entities. So if you have an SBoM, that can be very helpful in answering the questions that are asked of you about your software. Now, it might not just be one monolithic SBoM. You might break it up into different components to answer different questions. But the idea here, again, is that it can be a standardized way of communicating information across various parties that might be interested in information about your software. And the other thing that's important to keep in mind is that this can span not only across the various entities across space, but also across time. So if you have an archived SBoM, if someone asks you the same question in 10 years, you can presumably pull that SBoM from your archive and still answer all the questions that are required of you, even if you don't work for the company anymore or something like that. So when we talk about the software supply chain, what we're really asking is, what's in my software? Software in its final form is usually not easily, observable. It could be a binary, it could be embedded on a flash part that someone can't easily access. Even if it's like a plain text script, it can often be very difficult to figure out where that stuff came from. So we often have a lot of questions about what's in our software. Where did it come from? What version is it? Am I complying with the software licenses? We also would like to know if it's been tampered with, either intentionally or unintentionally. We want to know if it's vulnerable to exploits. Really, these are all just various forms of the same question, which is, can I trace the software I am shipping to my customers or distributing otherwise back to the source code that built it? We call that the software supply chain. So SBoMs can be used to describe the software supply chain. So for embedded build systems, or just about any build system, this is generally how we use it, right? So we've got a pile of source code here on the left, and we chuck it all into our magic box, and it spits out the widget, and that goes further on down the pipeline, or we ship it to our customers, or whatever it is, right? Now, it's very possible that your product looks something like this. And I'm not here to tell you whether that's a good thing or a bad thing, but I will say if this is what your product looks like, you really want to know that, right? So you can make the correct decisions about what needs to be done to ensure that you can continue to maintain your product or whatever it is. So we really need to know what it looks like inside of our products. If we break it down a little bit, this is generally what our build systems are actually doing at a very, very high level. We have various components, and some source code feeds into them, and then one component feeds into the next component, feeds into the next component to make our widget, right? Pretty straightforward, but this kind of ties back to that concept of components being related to each other that we saw earlier. Ideally, what we would like to happen is we would like our magic box to spit out the SBoM that then describes the widget that it produced. That's the easiest thing. Then we can use that SBoM to answer questions about our widget. So we have that here. And the important thing to keep in mind then is when these entities ask questions, in most cases, they're not asking questions about the software supply chain directly. They want to know, are there vulnerabilities in the product that you're shipping? What licenses are in the product that you're shipping or the thing that you're producing, right? These questions are always asked usually of the end product, not of the software supply chain. So being able to answer the questions about the thing you produced, the supply chain that produced the thing you produced, without having that supply chain and without having to give people access to that supply chain is very powerful. And that's really where SBoMs come into play, because if they can answer these questions about the supply chain, the supply chain doesn't have to exist anymore. Maybe it was an ephemeral build that happened at some point, but you've recorded that, so you can answer these questions just based on your SBoM. And that's very powerful, especially if your supply chain, again, is ephemeral or you don't want to give them access for some reason, right? In addition to our products being structured this way, it's also very possible that your magic box is structured this way. And again, maybe that's, not going to say whether that's good or bad, but if this is what your build infrastructure looks like, you really probably should know that that's what your build infrastructure looks like so that it doesn't break down on you someday unexpectedly. So we can actually extend our supply chain. And this is a very useful thing to be able to do also, where you can link the SBoM that describes your widget to an SBoM that describes your host infrastructure. Now, whether you need to actually do this and go into this depth is probably going to depend on your industry and things like that. But this is a valid use case in a lot of places. That's something you might want to do. And this, in particular, is really useful to answer questions about like supply chain attacks and things like that. Like, was my host infrastructure compromised when I built this widget, right? Or if there's a weak link in your supply chain, like, are all of our builds depending on the random developer in Nebraska, and when they quit, what are we going to do then, right? So, you know, we want to be able to keep making products. We need to be able to answer those questions, and that's where these host infrastructure SBoMs can come into play. And of course, the elephant in the room is regulatory compliance. So SBoMs are going to become increasingly required by regulatory bodies. You know, the big example of this would be like the CRA. Building SBoMs into your workflow now can save you a lot of headache when these become required very soon. You know, I'm not a lawyer, but the one advice I will give about like SBoMs and things like that is a lot of them use wording like, you know, you must produce industry standard SBoMs. So if your build system produces an SBoM, that's a pretty good indication that it's an industry standard thing that you can just use. And so that can really help you justify your compliance under a given law if your build system is just spitting out this industry standard SBoM. And you should all use industry standard when you're talking about these because it really helps us like say, yeah, we're producing these industry standard SBoMs. You know, we're good, we're good. And there's just a ton more other stuff that SBoMs are used for. Again, I do a lot of stuff with SPDX. So this is just a list of, I think, just some of the SPDX profiles that exist. So you can see people are trying to use SBoMs for all kinds of things that I am not covering here. And they're just going to keep expanding and keep getting more and more and more stuff in them. So yeah, that's a thing. So when we're specifically talking about the supply chain for embedded systems, I think there's a lot of strengths that embedded supply chains have that if all you've ever done is embedded supply chain, these might just seem like, well, yeah, sure, that's just how they work, but aren't necessarily common across all the ways that software is produced. So one of the things that embedded build systems have going for them is they usually have a very well-defined scope. Even if they're allowing arbitrary third-party software to be added into them, it has to be really well specified. Like you need a recipe or a package definition or something that describes how to build this thing. And that's because cross-compiling is really, really hard. You know, it is a very complicated thing to do properly, so we need everything to be pretty well specified in order to even build it in the first place. And if you kind of squint and don't look too closely, you can kind of think of these definitions of how to build something kind of as a form of SBoM. It's just a very like not interchangeable form of doing that kind of thing because it is specifying usually, you know, how do I compile this thing? What's the licensing information? You know, who's maintaining this? You know, stuff like that, stuff you would want in an SBoM. I'm not gonna say they are an SBoM because that's going a little too far, but you know, it has a lot of the same information in it. And a lot of times there's even a way in the build system to like dump this out as a JSON file or something like that. And that can be thought of as an SBoM. You could answer a lot of the questions that we have about SBoMs using some of those dumps of data. It's usually just a bespoke format, so not great for interchange. Kind of the point of this is like we already have, as the embedded community, a lot of the information that we need in our SBoMs in whatever our build system already is. So one of the things we can say is that we forward engineer our supply chain, right? We are building from source an entire system, usually almost entirely from source. We have extensive and holistic information about what we're building into our systems. We have to accurately be tracking dependency information because it wouldn't build if we didn't. And we usually have some form of license tracking. A lot of projects do that just because people really care about that kind of thing and it's important. So this is, we say our supply chain is intrinsically forward engineered, and this is the opposite of reverse engineering, right? There's a lot of tools out there that you can chuck a binary into and they will try to figure out what the process was that built it, and that's reverse engineering your supply chain, and that's fine. There's nothing certainly wrong with that. But I think as an embedded community, we certainly have the advantage that we can say we forward engineer our supply chain instead of reverse engineer it. And then another thing that we usually have going for us is host isolation. So just due to the nature of how embedded builds work, we usually need to isolate whatever we're building from whatever the host we're running it on is. And that's because we're cross-compiling, and also just we don't want host variances to cause a lot of problems with our end users because they might be using different operating systems to do builds, and so being able to build on multiple different hosts is a useful thing for our end users. This can take a lot of different forms. It might be containers, or you download a pre-built tool chain, or you building the tools that you need from source, or some combination of this. And this is really helpful from your software bill of materials and your supply chain, really, perspective, because it really minimizes that leakage of your host into your supply chain. However, as I have learned, it is quite tricky to express that this is actually happening in your SBoM, so we're working on that. And I'm familiar with Yocto, so this is just an example of what this looks like in the Yocto project. We start off over here. We've got a small set of host tools that we use, but it is really quite minimal, and that sort of gets us our host isolation. Any other tool that we are using, we're going to build from source right here. That we call those native tools in Yocto parlance, but kind of doesn't matter too much. And then we're going to use those tools, so we actually build like the cross compiler and stuff that you're going to use. We use those tools to build your target packages. Those end up in your target image, and then what Yocto does is at each step along the way, whenever it builds something, it spits out a little SPDX document, and at the end we combine those all together to make your final SBoM that describes your target image. So just as an example of how it's done. There are other ways of doing it. So what do we look for when we have an embedded SBoM? Ideally, we would get our SBoM output files in some standardized format. There are a couple of different ones out there to choose from, but that's really, if we're looking for exchange with other entities, we really want to pick something standardized and not bespoke. We'd like conformance with some standard for minimum elements. There's NTIA minimum elements out there. There's the CRA has a set of elements that they're looking for. And that's useful. I think there's other minimum element requirements out there. These are the two that I was aware of. And we'd also really like the build time dependencies because we have them, right? And that really gives a lot of depth to our supply chain that is very difficult to deduce after the fact, right? So putting them in while we're doing our builds can be really useful. And we also want the licensing information. That's a very common thing that people want SBoMs for. And also vulnerability data is also very important and something that people almost always want from their SBoM. And then I got to put a plug in about reproducible builds because that's my other thing that I do. Reproducible builds, it's being able to reproduce byte for byte what you built, and preferably across time. So if I built something today and I build something 10 years from now, I want them to be byte for byte the same, and that's ideally what we would like to go for. Now in embedded systems, particularly with how flexible and how extensible they are, generally if a project says we are reproducible, that doesn't mean the exact widget that you're building is reproducible because the upstream project probably doesn't have all the resources to test everyone's exact build configuration, right? Usually it just means they provide the infrastructure or the framework for making your builds reproducible, but the onus is on you to test your builds to make sure that they actually are reproducible, the things that you actually build. If your project is listed on reproduciblebuilds.org, that's a bonus. If you've never been to reproduciblebuilds.org, it's pretty cool. They do a lot of fun stuff there. They also provide a really awesome tool called diffoscope, which is really good for diffing things and figuring out where non-reproducibilities are. And it provides strength to your supply chain, right? Like if you can do a build now and say you can do the same build in 10 years, that really lends a lot of strength to the statements you are making about your supply chain. Okay, so I'm gonna really quickly go through some of the projects. I looked up a couple of them to try to figure out what kind of support they have for SBoMs and reproducible builds and things like that. And I am not trying to shame anyone, just to be clear. This is not a shaming thing. I'm trying to highlight what's there. So if you're using one of these projects, if you didn't know they did this, you should start using it because it's great. So we'll go through that, and of course we'll do Yocto first because that is what I do. So Yocto has had SPDX support since the 3.4 release. It was 2.2 originally, and then we switched to 3.0 and 5.1. Please use SPDX 3. It's much, much better for what Yocto outputs. And we do have reproducible build testing. We test that, I believe, every day, and you can see the build results there. Again, we're just testing the upstream core stuff. Everyone's Yocto build is basically different, so please test your own to make sure. I did look up BuildRoot too, and they have this BR2 reproducible flag, so that's awesome. Having support for reproducible builds is great. And I did link to the wiki thing there that kind of describes it in a little more detail. And they have a tool that will output Cyclone DX SBoM output, and I believe they output an intermediate file, and then this converts it to Cyclone DX or something along those lines. Yeah, people are nodding, so that's good. I got it right. And it's a GitHub project right now. I think they're working on integrating it into the main project, or it is integrated. I'm not exactly sure the status of it. So either way, this is still really useful. Give you your SBoMs that you need. It's really, really good. Zephyr has support for SBoM support. They made it really easy. You just do west SPDX and then your build directory, and it'll spit out an SPDX 2.3 SBoM. And that's great. I put the link to the information about that. I couldn't find anything on reproducible builds for Zephyr. Being an embedded RTOS the way that it is, I think it's probably pretty easy to test that yourself. There's a huge difference between testing that a binary RTOS is reproducible versus an entire Linux distribution. So, probably a lot simpler there for the end users to just do that. And then Apache NetX RTOS. I wanted to mention this one because I was at FOSDEM and they did this really good presentation on how they added SPDX 2.3 support. It was really, really pretty cool to see that and the process that they went through to add that. So if you're using that, that's great. And if you didn't see your project here, again, I'm sorry. I might have just missed it. It's very possible. I'm not trying to shame anyone, I promise. But this is important. So if your project that you're using to do your embedded builds doesn't have this, ask around. Like I said, the embedded build systems tend to already have all this information, so it's generally an exercise in, reformulating it into a standardized format. So generally, that's, I don't think, too terribly difficult. So, again, using Yocto as an example, the Python code that converts the information we already have into SPDX is about 2,000 lines, and that's not really that much at the end of the day. It sounds like a lot. It's not too bad. It's also really good public relations for your project. If you can say, yeah, just do a build and you get the SBoM. It's great, people really like that kind of thing. And if you have questions about implementation, I can provide general guidance on how to massage your data and what kind of structure you could need. If you have specific questions about SPDX, I can help with that. And also specific questions about Yocto, obviously. I can answer questions about that too. So does anyone have questions? I think we have about 15 minutes left. I went way faster than I thought I was going to go. So it's okay. It's okay. We got good questions. Who's first? I like to talk, so
Yeah, I'd like to hear how you actually use SPDX files. For example, I've got a bunch of them from my Yocto build, and I can see they're in JSON, but what tooling exists to do something with them?
Yeah, so I didn't get to highlight too much of that in my presentation. I probably should have put it in there. The tooling is coming along. So one of the problems that we had with the SPDX 2.3 is that the volume of output that we produce was a little bit much for a lot of the tooling. Just for reference, like a 100 megabyte root file system that you built in Yocto could have like 500 megabytes of SPDX data. It was crazy. It's crazy, and that's like, and there's like flags you can turn on to get more, right? So I think that was one of the problems we had with SPDX 2.3, and then also just the way we were generating it in Yocto. We had to generate a bunch of independent files that were like linked together by references, and a lot of the tools didn't like that as much. So that was always a problem. SPDX 3 is a lot better. We can produce a single JSON file that describes your entire build, so that helps a lot. And the SPDX 3 tooling, like I've written a bunch of Python tools for SPDX 3, and we're trying to get it into ProtoBOM also, which is one of the main like lingua franca, SBoM things, right, where you can put in any SBoM and it can deal with it. And a lot of tools are built on ProtoBOM. I don't see the person I'm supposed to talk to about that while I'm here. But yeah, can you pass the mic?
Thank you.
I don't want to walk in front of the speaker. It's going to shrill again. I guess short answer, it's getting better. Yeah. I say that every year. It's getting better,
Thanks, Josh.
Yeah.
I know this is a politically charged topic, so you can choose not to address it. Do you have any visibility into the state of the CVE databases?
No, that's not I have no idea.
Okay. All right.
It's not that I don't want to answer. I have no idea. That's not my.
We're on a 6-month review.
Yeah, I don't know.
Funding for the next 6 months.
We can just work on. Oh yeah.
Great, thanks. I have a general question about CVEs in the SBoM.
Yeah.
What's your thoughts about including that, seeing as the longer the SBoM exists, the more out of date they get?
Right. So you need. I think it's important to have two pieces of information. So, and there's a lot of different ways of doing this. So the first piece of information is pretty straightforward. What software is in there, and how do I tell if it has CVEs in the future, right? So include a CPE, or I've heard people talk about maybe switching to Perls. I don't know. That's a thing. But include the CPEs for what's in your system at a bare minimum. And the second piece of information is, a lot of times when we're talking about these embedded build projects, they a lot of them take a lot of great pride in patching CVEs for you, right? And so it's really helpful to be able to know what CVEs have already been fixed. Now, in Yocto, we just put that in the SBoM. So it says like this is the CPE, and then we list out these are the CVEs we've patched. And that's expressed in the SPDX data, SPDX3 data. So if you were to run it through a tool that doesn't exist yet, once the tooling catches up. So if you run that through a tool, it should hopefully tell you, like, these are the CVEs we found for this project. Oh, and these ones were already patched, right? And so that is expressible in SPDX, and we have done that. So, that's really useful information, because it would also be a shame if like people had to figure out whether it was vulnerable to a CVE that the upstream project already took care of, right? So those are kind of the two main things that I think would be nice, with the CPEs obviously being the most important, right? You want to be able to know whether you have them or not in the first place. But
Yeah, being able to continuously monitor that over
yeah,
the
exactly.
course of a product.
Yeah, exactly,
Yeah.
right? And that's so, when you do your build, you can throw your CVE, your SBoM into a database or whatever and track that going forward. So yeah, I think, yeah.
You're close.
So do you know we can backport the SPDX3 for ScarCap and we can generate like single JSON file?
Maybe. There has been interest in doing that. I think that will maybe happen in some capacity would be my guess. I couldn't give you a timeline for it though, I'm sorry.
Okay, thank you.
Yeah, sorry.
So I am one of the folks that's here. You heard FAIR be announced this morning if you were at the opening remarks and such. In the WordPress space, I took part in a hackathon event at CloudFest. This is leading up to the question. That was around, the group I was with we made a project, SBoMinator, because why not name it something great?
Yeah.
So taking these various formats, and I live more in the CMS world of things. I am wondering where the urgency is at this time for SBoMs that are more relevant to mid-market end consumers, mid and enterprise end consumers, right? Because I work at GoDaddy, and we certainly need SBoMs with our CISO department and all of that. But SBoMs are an initiative that also could impact, I see it very much in Europe. CRA is absolutely pushing the need for the ability to quickly have an SBoM if you're in a certain level of business or more. In North America, particularly in America itself, I don't know that your average small business owner website is going to care much about SBoMs, but certainly mid and upper market will. Where is the urgency for SBoMs that interface in the end consumer area? Sorry, that might be a little loaded, but like, do you feel like it's really urgent right now that we get this all done? Or is it that, I remember it being announced on CISA.gov/SBoMs. Certainly, I have been part of the working groups with that, in fact.
Right. Yeah, and I don't quote me on this, but I want to say you have to have SBoMs if you're shipping to the government, the U.S. government at this point. But I'm not sure about that. Don't quote me on that, please. There is no, as far as I'm aware, there's nothing requiring consumer electronics sold in the United States to have SBoMs, right? I think that's pretty clear. I think having them is useful, again, because you might not be able to reproduce your supply chain from however many years ago you built your product. And so having that in a machine parsable format could be extremely helpful and save your bacon at some point, right? I know that's a really unsatisfactory answer, like, oh, build them now and chuck them in a salt mine and deal with them later, right? But that is kind of, I think, one of the main things at this point. But there, I think more and more open source compliance offices are probably going to be utilizing them in order to do compliance, just because it tends to get to the point where you don't want to pay someone to go sift through every single software package you have and look at the licensing information. Who wants to do that? They're not going to be with the company very long if you make them do that every day. So I think that, that's where we're hopefully getting to. I don't really have a good visibility on how widespread that is in the consumer product ecosystem. Does anyone else have a question? We have 5 minutes left.
I see a hand.
I don't know if I have to stand for this or not, but
Whatever you're comfortable with is fine.
you said there was instead of like a monolithic SBoM, like there can be like multiple types. So like I wonder like what are the like more common like derivatives, I guess, of like those SBoMs, because I work in on FPGAs, so I'm just trying to think of like, okay, I work at Honeywell, so I'm trying to think of like where they could try to fit us into there, because I think they might try to they might, keyword is might, they might try to do something with like SBoMs like into some of their more traditional like software packages and stuff like that. So I'm just trying to see like where would, you know, some of that come in.
Yeah, I don't deal a lot with the hardware stuff. However, I will say, like, if you are interested in that kind of thing, get involved in an SBoM community, SPDX, CycloneDX, something. Like, I know SPDX is doing a ton of stuff with hardware. I'm not personally involved in it, so I don't want to speak too much to it. But I think it kind of goes back to, you know, the keynote talk, right? Like, if you get involved now, you can have a lot of say in the direction of that and where that's going, and that could help you a lot down the road. So as an example of that, like I got involved in the build profile for SPDX3 pretty early, and that played it just so happened that the build profile played very nicely with Yocto, right? Surprise, surprise, right? You know, like that can really pay benefits to get involved in one of your SBoM communities now, because a lot of this stuff is starting to change. They're doing a lot of change right now to account for a lot of stuff. So I would highly recommend that. You know, if you want information about SPDX, Gary's there in the back. He can tell you all about it and how to get involved with that. I'm sure there's CycloneDX people here too. I'm sorry, I'm not involved in that. So,
Okay.
But yeah, so that would be my statement there.
Thank you, Josh. Recent our headache is a relationship object. As you know, embedded system has already many relationships between the components, but adding the OpenBX or security information, time by time, the relationship object will be more increasing. Many relationship objects will be generated time by time. So what do you think about on this?
I think it's very complicated. I don't know. I don't know the answer to that problem. I think, are you talking about like each time you do a build, you get a different thing? Or each time you do a build, like it's trying to describe a thing that happened, and so it gets expansive each time you do a build? Or are you talking about like you create the SBoM at one point in time, but then things change over time? I don't know, I wasn't quite sure which one you were referring to.
So one time, once we found the vulnerability, we will create the BEX object and create a relationship object.
Right.
But once patched and fixed the vulnerability, we needed to change the relationship object, also BEX status.
Right.
So we needed to reproduce the SBoMs and provide the customers. The operation is very complicated and
Yeah.
yeah. And,
It is very complicated, and it kind of depends on what you're going for. So, you know, if you're in the situation that you're shipping a consumer product, right? I think it's reasonable that every release of that product, you're just going to have the SBoM that goes with that product. And when you patch something, that'll show up in the next release, and that will be a different SBoM, right? And I think for now at least, that's perfectly fine. And that will track that progression over time a little better. You know, you know, embedded systems are wide and diverse, right? But I think for at least the case where each time you do the release, you're doing the full build of the thing, and just that's what it is. It is one monolithic thing that you end up producing. Then, you know, I think that makes sense. You know, I don't think we're in this situation. Some people are, but you know, we're not as commonly in the situation of like a desktop distro where it's, you know, things are runtime package management and stuff like that, right? So not that that doesn't happen in embedded, but I don't think that's the norm based on where I've seen. So even if you are using package management, it's usually still like you're fixing this thing in time. And that's just kind of the world of embedded. So it's a little easier in that regard. So
Thank you very much.
yeah. I think I'm out of time. Yeah, I'm out of time. I'm getting the nod, so I'm out of time. So you can feel free to talk to me in the hall or whatever you want to do. So cool.